Let's see how to solve this problem. Equal number 802. Find eventual safe states. Let's see the question. Uh, there is a directed graph of n nodes. So what are we given? So we are given a directed graph. It has n nodes. So nodes are from 0 to n minus 1. The graph is represented by 0 index to be a graph is an integer of nodes adjacent to I, meaning we are given an adjacency list. So a node is a terminal node if there are no outgoing edges. A node is a safe node if every possible path starting from that node leads to terminal. So we are given two words which are terminal node and safe node. So if a node has no outgoing edges, node which has no outgoing edges, okay, and that is safe node. What is safe node? A safe node is every path, a node whose every path leads to terminal node or another safe node. Return an array containing all the safe nodes. Okay. Return the result in ascending order. So this example might look a little complex. Let's take our own example and let's understand the question in a better way. Okay. So let's take this as our graph. It has 6 nodes n equal 6 and which are 0 to sorry, it has 7 nodes and 0 to 6. Okay. Hmm. 0 to 6 nodes and it is a directed graph. That much we know right now. And we need to return the safe nodes. Yeah, let's see what are the terminal nodes. Forget about code, let's see directly for now. So a node which has no outgoing edges. This has an edge, outgoing edge. This has an outgoing edge. And this has an outgoing edge. This has 6 has no outgoing edge and 4 has no outgoing edge. So 4 and 6 are our terminal. Let's see safe nodes. Okay. So they asked us to return the all the safe nodes here. So let me see. Containing all the safe nodes. Here actually a terminal node also can be a safe node. We can consider that. So let's see the safe nodes. We should return the combination of safe and terminal. Okay. So what the terminal nodes? A safe node is a node whose all the parts leads to another safe node or terminal node. Let's see for 0. If I go from 0, I'm coming to 1. 1 to 5, 5 to 6. It is leading to a terminal node, one path. So we need to check all the paths. This is one path. Let's see second path. 0, coming to 1, coming to 2. We are again coming to 0. Second path is not reaching to any safe node or terminal node. So 0 can't be my safe node. I check with 1. Similarly with 1 also. This will lead to a safe node, but this will again lead to 1. Similar case with 2. Let's check with 3. So I'll go here from 2 to 0, 0 to 1, 1 to 2. Again I'm reaching to 2. So I'm not able to reach here. So 3 cannot be my safe node. Let's check with 4. I mean 4 and 6 are terminal nodes. They're already visited. Think of them in that way. Let's come to 5. Okay. From 5, let's see the paths. The only path is 5 to 6. So if you start from 5, you're able to reach the terminal. So 5 will be my safe. So I need to return result in ascending order 4, 5, 6. So I need to return this. So if you observe one thing, we got 4, 5, 6 as our answers. And we didn't include 0, 1, 2, 3. The reason behind it is 0, 1, 2 are not included because they will never reach to a terminal node because they will form a cycle. So even one path reaches to a terminal node, there will be another path definitely which will again come to that node if we keep on rotating in between those nodes. So they will never come under safe nodes. And why we didn't got 3? So that is because if you enter into any cycle, you can never come out of it. So we can write the statement in that way. All nodes which are included in cycle can't be my safe nodes. Next, all nodes which is to cycle can't be my safe nodes. So the remaining all can be safe nodes. Let's see how can we solve this. Let's take 3 arrays, 3 boolean arrays. One is visited. Okay, let's keep all of them as not visited right now. So we need 7. So let's write indexes. 0, 3, 4, 5, 6. Similarly, I need another 2 arrays which are need to check whether a node is included in my path or not. And another is uh, to keep a tick mark of all the safe nodes where we're traversing. Let's start with the node 0. Okay, so I'll start with node. Is it visited? It is not visited. I'll mark it as visited, and I'll keep it in my path. So I'll come to 1. Is it visited? It is not visited. I'll mark 1 as visited and I'll add it in my path. Okay. I'll come to 2. So is 2 visited? I'm checking all the possibilities. Okay. So I'm coming to 2. Is 2 visited? It is not visited, and I'm marking it here. Okay. Yes. So I'll mark 2 as visited. I'll see the neighbors of 2, which is 0. So 0 is visited. Okay. And it is also in my path. So it cannot be my safe node because so logically we entered in a cycle. So we started with 0 and we reached a cycle. So 0 can't be my safe node. I'll come back. I'll mark this as visited, but I'll remove the paths. Maybe I can through another path. Maybe I can get some other node. I removed 2 from my path and I came back to 1. From 1 I went to 2. I'll check on path which is 5. I'll go to 5. Okay. I'll come to 5. So is 5 visited? Actually, before going to 5, we need to do one thing. So if we encounter any cycle, we shouldn't go further because even if we go to 5 and 6, they'll be treated as not exactly in part of cycle, but somewhere we started with cycle, and these are a branch of cycle. So let's stop when we reach the cycle. Okay. So I'll remove them from my path. So I don't no need of removing it from the path. I'll keep them in path. So I'll keep them in visited also. These can't be my safe nodes. Because if I keep them in path, they'll be helpful for me. Because if any node that reaches to this path, these three paths, it can't be safe nodes. So let's start with one. Is one visited? It is visited. Now check two. Is two visited? It is visited. Let's check with three. Is three visited? It is not visited. I'll mark it as visited. I'll keep it in. I'll mark it in my path. And I'll see its neighbors. What are its neighbors? It's two. I'll check. Is two visited? It is visited. And also it is in the path. Okay. That means it is involved in a path which led to a cycle. So 3 is involved in a path which forms a cycle. So 3 can't be my safe node. Let's start with 4. Okay. So if you go to 4, what are its neighbors? Let's mark it as visited. Let's keep it in our path. So let's check its neighbor. Are there any neighbors? No, there are no neighbors. What I will do? I completed all of them, and I'm able to came back to 4 in get of in that. Right now there are no nodes, so we are at 4 only. So 4 can be my safe node. Take it, I remove it from my path. So now I'll start with 5. So is 5 listed? No, it is not listed. So I'll mark it in my path, and I'll see its neighbors. What are its neighbors? 6. Is 6 listed? No, it is not listed. I will mark it in listed. And also I will mark it in path. Okay. So from 6 I'll try to go to its neighbors. Are there any neighbors? No, there are no neighbors. What I'll do is I finished all the neighbors of 6. So I'll mark it as safe node. I'll remove it from my path. And will come back to 5. I'll see its neighbors. 6 is completed, and are there any neighbors? No other neighbors are there. So I'll mark it here. So it is completed, so it is safe. And I'll remove it from my path. So 5 is done. Let's come to 6. Let's check 6. 6 visited, it is visited. So I have visited all the nodes and I have marked the safe nodes. So I need to check the array, and if it is 1, I'll add it to my result. 4, it is 1, 5, 1, 6, 1, and sort it, and we can return it. So that's how we can solve this. So let's write code for this. So what are we doing? Let's declare what we need. So then the number of vertices. This integer. This is a result. Okay, and we need it is already an adjacency list, I guess. Yeah, it is already an adjacency list. So what do we need to do? We need 3 arrays and visited, boolean outcome, and a path, boolean outcome, and what else? And safe, boolean outcome. Okay. I need to check all the nodes because there can be many components. Certain node is not listed. I'll do DFS. So DFS will return me something. DFS will mark all the things. You don't need to return anything here. DFS will mark whether it is safe or not. At the end, I will have everything filled in a result. So I need to sort it. Collections, sort out result, and I need to return the result. Let's see, let's write a DFS function. What do we need? What is my current node? My three arrays, visited, path, save, my graph, and number of nodes. Build path, save, into, okay. Then we need to mark them. First we need to mark them as visited of node 2, visited of path also 2. Now let's check its neighbors. Neighbor graph of node. Okay. If it is not visited, I mean if the neighbor is not visited, we'll visit it. What I'll do? I'll do DFS something. I'll write. Okay. So if it is visited and also it is in my path, so that means I got my cycle. So I'll return to. So okay, I don't need to, no need to go further. I got a cycle, so this cannot be my safe nodes. So the DFS call which was made will again check this. I'll call my neighbor, visited path, say graph. If this returns true, I'll return true. So I won't go below the for loop. That means if it's written true, it is through a DFS call. It can be from here, it can be from here. So uh, those nodes cannot be my sequence. Uh, those nodes cannot complete this for loop. Okay. So if any node was able to complete this for loop, that means it visited all its neighbors and they are safe nodes. That means I'll mark them. So I got my safe node. This is a safe node, and I'll remove it from my path. Sorry, this is path of node. And I'll return false. Okay, we have an error. Never visited paths with graph. So, it won't return anything. Let's write boolean here. Graph, and it should be healing got our expected answer. Okay, so I didn't fill them in the result. So I think I don't even need to sort them since I would be iterating in a for loop. 0 alias and I plus plus. If it is safe, add it to result, and at the end return the result. Hmm. So expected 4, but it didn't got 4. Okay, so it's summation. 4 can't be visited from anywhere. I'll come here. Let's keep it in path. Let us print the safe array. Okay, it should be path. my bad, it is safe. Hmm. That's it. Hmm. So as expected, it is false for 0, 1 and 3. 4 is also false. Why is there are no nodes that lead to 4? So 4 would be not visited. I'll apply DFS on 4. For market is visited and keep it in path. And I check its neighbors. If neighbors are 5. Okay. So if it is not visited, no issues. It is visited and need to keep this false. Okay. Not true. Hmm. Yeah, now it is working. Let's submit this. Yeah, it got accepted. Let's analyze the time and space. Time. Mm, this is a big offhand. This is a big offhand. Two big offhands. And we have DFS. So max it will be big of edges only. Big of edges. So since it is a directed graph, it won't be 2 into e. If it is an undirected, so we will visit each edge twice. So this the time. Since it is directed, it's big of e. Space. Have 3 boolean arrays and a result big of 4n, and this is a recursive stack space big of 5 into. So that's it. Thank you.